Right, hello. Today we're going to do a very fun integration question. It's from MIT's Integration Bee from this year, 2022. It's part of the qualifying round and it was question number 10 in the qualifying round. I'll leave a little link to it below. The integral itself is from 0 to 1 and it's e to the x, take away e to the x minus x. So this minus x is part of like this e to the x minus x over here. It's a part of the exponent in this part. First thing we're going to do is we're going to do a substitution and we're going to let u equal e to the x. So that tells us straight away that x is the natural log of u. And also then we can think about what our limits are here. So u of 0 is, if we plug in 0 to this, is going to give us 1. And u of 1, if we plug in 1 into this, is going to give us e. Similarly, if we look at the dx here, if we do du dx, so if we differentiate u with respect to x, what that gives us is e to the x, which we know is just equal to u. So we can kind of rearrange and say that our d of x is equal to du over u, like that. Very nice. So let's take all these parts and rebuild our new integral in terms of u. So we still call it I. I is equal to the integral from not 0 to 1 now, but 1 to e. E to the x, or e to the x is u, so e to the u, minus e to the u, minus, which should be x, but x here is not ln of x, sorry, that should be ln of u, minus ln of u, like that. Everything now then should be d of x, but d of x is going to be replaced by du on u, du over u, like that. Beautiful. Very nice indeed. Next step then, we're going to sort of deal with this horrible thing over here. Because if we have e to the power of the natural log, those two things cancel out with each other. So we'll try and get that bit to appear. So we'll keep our limits of integration. E to the u just stays the same. This thing can separate out then to be e to the u over e to the ln u. And we know this e to the ln u is going to cancel down just to be u in a second. We still have this as du on u. And let's just do that little cancellation. So 1 to e to the u, minus e to the u over u, and then everything is still du on u. I'm going to take this u and sort of distribute it over these parts here, over these terms. So our limits stay the same, 1 to e. We then have e to the u on u minus e to the u on u squared, all being integrated with respect to u. Beautiful. So from here then, the next step I'm going to do is we're going to remember, so we need to remember that e to the u is equal to 1 plus u squared on 2 factorial plus u cubed on 3 factorial plus etc, etc. We'll actually put, we'll put the fourth in there just for completeness. 4 factorial plus etc, etc. So we'll take this and we'll substitute this thing inside of our integral here, and hopefully that's going to help us a bit. So our I is equal to the integral of 1 to e of our little thing inside. So it's now going to be 1 over u, lots of this. So 1 plus u squared over 2 factorial plus u cubed over 3 factorial plus u4 over 4 factorial, etc, etc, plus 1 over u squared, 1 plus u squared over 2 factorial, u cubed over 3 factorial, plus u4 over 4 factorial, etc, etc. All being integrated with respect to u. du. Very nice. So next step from here then is we're going to actually distribute our 1 over u and 1 over u squared over all the terms in here. We could have done this with a summation, but I think it's kind of just easier to see it term by term in this when you see the cancellation in a second. So next step then, from 1 to e, always staying the same with our limits. This is 1 over u plus 1 plus u over 2 factorial plus u squared over 3 factorial plus u cubed over 4 factorial, etc, etc. So we can see here we go, if that's n plus 1. And then looking at these terms over here, we don't need these brackets so much, but it's nice to see sort of the bits that there's still two different parts, if that makes sense. This then, 1 over u squared plus 1 over u plus 1 over 2 factorial plus u over 3 factorial plus u squared over 4 factorial, etc., etc. Still integrated with respect to u on the end. Now then, we'll kind of have a look, and I've realised that these should all be minuses in the middle, not plus, but that's completely fine. You can just do that. So now, yeah, we're going to look and see if any of these terms cancel out. We've got 1 over u and 1 over u. Nice. So they cancel out straight away. 1, there's no 1. U over 2 factorial doesn't exist there. So we can see that from that, I don't think there's going to be any more that are going to cancel out. Just this first one and this second one here cancel out. From that then, we're going to use the rest of the terms and collect the like terms. So our limits still go from 1 to e. In terms of, we've got 1 over u squared. There's no 1 over u's anymore, but the u to the minus 1 is all, they've all cancelled out with each other. Let's have a look at constant terms. We've got a 1 here. I'll put things in brackets. 1 here, and these are all going to be take away on this side. So minus 1 over 2 factorial. I'm actually going to rewrite this one as 1 over 1 factorial, which is completely fine to do. And in terms of what we had here, that's really how it should write it. It should be written as u over 1 factorial. We'll look at the second terms then. Oh, so they should all have, oh no, they're constant. Let's add the u terms then. It's going to be 1 over 2 factorial. Take away 1 over 3 factorial. For u squared, it's going to be 1 over 3 factorial minus 1 over 4 factorial. And etc., etc. This is going to keep going. Still all integrated with respect to u. Some people might recognize, like you think like, oh, this minus and this plus of the 1 over root 2 might cancel off somehow. But they've got different coefficients of u. They've got different powers of u, even, sorry. So they're not going to cancel off too easily. The next thing we're going to do then is we're going to kind of have a look at the constant terms here, the coefficients of our powers of u. So we're going to inspect. And the general form of it. So it's 1 over n factorial. Take away 1 over n plus 1 factorial in each case. If we think like this is n plus 1 is 3. If 3 is n plus 1 is 4. Oh no, we're not doing that yet. No, we will do that now, that's fine. So from this then, let's multiply this term over here, top and bottom by n minus 1, n plus 1 even. We have n plus 1 over, well, if this is n factorial and we multiply by n plus 1, we end up with n plus 1 factorial. And still take away the second term, n plus 1 factorial. So now when we turn these into one fraction with the same denominator, we have n plus 1 minus 1. So that's just n, nice and easy. So it's n over n plus 1 factorial, like that. So all of these coefficients of our powers of u can be replaced like this now, where n and n plus 1 is like n is 1 here and n plus 1 is 2, n is 2, n is 3, etc., etc. So let's rewrite our entire integral. 1 and e. The 1 over u squared just stays the same, that's chilling out the front by itself. Plus then, so this is going to be 1 over 2 factorial, like that. The next thing, in terms of u, how many have we got? Well, it's going to be 2 over 3 factorial of u plus 3 over 4 factorial of u squared plus 4 over 5 factorial of u cubed, etc., etc. We can do as many times as we like, but I'll stop there. So next thing then, we're actually going to integrate now. We've got down to a point where loads of terms and they're all just in powers of u, so something that's nice and easy to integrate. So let's think about that then. We'll take the big square bracket. This is u to the minus 2, so it becomes u to the minus 1, divided by minus 1, just put a negative sign in the front. This thing, u over 2 factorial. This next part then is going to be, well, u squared. So you divide by 2, so it's just 1 over 3 factorial. The next part then, it's going to be u cubed, divide by the 3, so it's 1 over 4 factorial. The next part, u to the 4, divide by the 4, so just 1 over 5 factorial. Very nice. This keeps going for as long as we want to do it. And now we're no longer integrating because we've already integrated, but our limits are going to be from 1 to e, the same limits we had over here. Hello, it's me from the future, but also from the past. I missed off a minus sign. this 1 over u squared, it should have had a minus here. I didn't put it on there. Add a minus here. And there shouldn't be a minus there, but there was one. And then you carry on going, and it does work out, because the minuses, 2 wrongs make a right, apparently, in this case. But there should be minuses, and there weren't. And then there shouldn't be, and there was. But I carried on going in the correct manner here. So sorry about that, but everything else I think is fine. Next step then, I'm going to take out a factor of 1 over u. So if we think about how we started with e, it was like u squared over 2 factorial, u cubed over 3 factorial, u to the 4 over 4 factorial. Here we're very close, but it's kind of like we're 1 missing on the power. So if we take out a factor of 1 on u, what that does is that this will become a u cubed over 3 factorial. This will be u fourth over 4 factorial. So it will be in the same form as it is up here. It will make this part though into, I think we've basically taken this out, so that's going to be 1 plus then u squared over 2 factorial plus u cubed over 3 factorial plus u4 over 4 factorial, etc, etc. And at the end though, we still have to put in these 2 limits. Now this is very similar to e to the u, but we're missing off just our u term, basically, the u term that we had in here. So we can write this then as 1 over u, lots of e to the u minus u. Nice and simple. Still with our limits of integration. And now we'll substitute those things in there. So what we have is 1 over e, lots of e to the e minus e. All take away. Don't actually need the square brackets, but it's still quite nice. If we put 1 in there then, 1 over 1 is just 1, nice and easy. E to the 1 is going to be just e minus 1, like that, beautiful. And we'll make that a square just to keep it the same. If we start then expanding these things out, well, we get e to the e over e minus, well, e over e, they're the same thing, so they're going to cancel off with each other. So that's just going to be 1. And then if we look at this second term, minus e plus 1. This minus 1 and this plus 1 will cancel. And what we're left with then is e to the e over e, take away e. And we'll look at this first term, and we can kind of cancel off one of the e's, and we're left with e to the e minus 1, take away e. And that's the problem solved. Very nice problem. Yeah, very nice indeed.